Okay, today and tomorrow we are just going to do a basic overview on naming and drawing organic compounds, only because our next unit is Lewis dot structures. Do you remember that?
Yeah.
We have to draw them. Okay. So because the AP exam is just not easy, likely that structure is going to be an organic structure, and I don't want you to be intimidated by it. I want you to be familiar with it. So we're going to spend 2 days working through this. On Thursday, we are doing a take-home organic assessment. So if you're here, you're doing it with me in class. If you're not here, you're doing it at home with your friends and the internet. So like your choice on that one. And then Friday, we're taking our chapter 10 class. So an alkane is a straight chain hydrocarbon. A hydrocarbon is just like it sounds. It's carbon with a bunch of hydrogens on it. No matter however many carbons there are, the formula is always CnH2n plus 2. That's a 2. 2n plus 2.
Just like that plus 2.
If the organic compound has one carbon, we call it methane. So methane is actually one of the compounds that you have to memorize, just like carbon dioxide or water. It's CH4, okay? And that's because carbon can make 4 bonds. And when we draw the bonds, we draw them like a crisscross. In real life, are they flat and crisscrossing? No, they are not. Yeah. But the way that we draw them on paper is going to be flat and crisscrossing. If our carbon chain has 2 carbons in it, we call that ethane. And the formula is going to be C2H6. So that means we have a carbon bonded to a carbon. Each carbon gets 4 bonds. So that is where our 6 hydrogens come from. 1, 2, 3, 4, 5, 6. If it has 3 carbons, we call it propane. Might sound familiar to you. C3H8. I'm drawing this over to the left of the box on purpose because I'm going to draw something else to the right. So I'm scooching left on purpose. So C, C, C. Each carbon gets 4 bonds. So that's how come we end up with 8 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. Since drawing all the carbons and hydrogens can get like crowded, they came up with a different way, an alternative way to draw organic molecules. They're called line drawings. Okay? So line drawings, instead of being crisscrossy and flat, are not. They're going to be jig-jaggy. Each corner represents a carbon. Yep. 4 carbons is called butane. C4H10, just like, oops, I wrote 18. Just like our lab. So 4 carbons. Each carbon gets 4 bonds. So that is where our 10 hydrogens come from. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We could also draw it as a line drawing. In a line drawing, each of the corners is a carbon, and we do not draw the hydrogens, but that does not mean they do not exist. They're understood. So that also doesn't mean that you don't need to know that. You do need to know that. Just because they're not on here, you would need to know how many there are and where they would be. 5 carbons is called pentane. and that's C5H12. Six carbons is called hexane. C6H14. Seven is called heptane. C7H16. On the periodic table.
Oh my God.
8. Can you guess? What is 8? Octane.
9 is 19.
Nope.
Non-tane.
Nope.
Non-tane.
Nope. Close though.
2.
Dodecane is 12. Nonane.
What is it? Nane?
I thought you said non.
Nane!
Oh, then you were right. Witness on that corner.
Maybe you should do that as we're going. Maybe you should.
C decane, I'm sorry, I didn't say 10 is decane. C10H22. And then when the music starts, read them to somebody twice. Methane all the way to decane to help you remember the order. Read them twice.
Yeah,
Okay. So organic compounds are not going to be just straight like that. So that's where the hard part comes in, learning how to name them. Those are called isomers. Isomers have the same formula but different structures, which will give them different properties. They behave different. Okay, so in our gas lab, we use butane, and it's in liquid form when it's in the lighter because it's under a lot of pressure, but then when we push the button and let the pressure off, then it becomes a gas. So butane is 4 carbons. Each carbon has 4 bonds. So then that is where our 10 hydrogens come from. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
And you know this board.
That's what butane is. You just said that like 5 times.
Are you literally writing through?
Okay. So now an isomer means that the formula is still C4H10, meaning it has 4 carbons and 10 hydrogens. But the name is different because the structure is different. This is just going to be an introduction. I'm going to tell you how to do it. 2-methylpropane. Propane is a 3 carbon. 2-methyl means that off of the second carbon, I have a methane. And a methane is a 1 carbon. But every carbon still gets 4 bonds, so I still end up with 10 hydrogens. It's an isomer because it's still C4H10. It just looks different and has a different name to it. Okay? When we name organic compounds, it tells us what the isomer is. It tells us the shape and where everything is. There are going to be 4 steps to naming. We're going to use 2 different colored highlighters. If you ask me why these are the rules for naming, my answer is because 100 years ago, some old dead white guy decided it. This is arbitrary, but these are the rules, and this is how we have to do it, okay? So, step 1, you are going to find, I'm going to use my yellow highlighter. You are going to find the longest and continuous chain of carbons. So watch me. I'm going to do it wrong at first to make a point. So don't do this. Just watch me. So the longest continuous chain could be anywhere. This is a chain, all connected. That's 1, 2, 3, 4 carbons. I'm going to assume that's not the longest. Another way I could do it is straight across. That's 1, 2, 3, 4, 5. Longest continuous. Okay, 5 is my longest. I could do this. That's 4, not longer. I could go this way.
That's 5.
Tie. If you have a tie, your name is going to work out to be the same thing and it's totally fine. I tend to just go straight across if I can, so go ahead. We're going to go straight across to learn for the first time. 1, 2, 3, 4, 5. Now I'm going to pick up my second highlighter is going to be green. Ooh. Yours can be whatever, mine's green. Step 2, after I find the longest continuous chain, is to find what are called substituents. Substituents. When I say go, say substituents. Ready, set, go.
Substituents.
Substituents are things, not hydrogen, that are connected to and hanging off the chain. So they're not part of the main chain, but they're not hydrogens either. In this case, my substituents are carbons. They do not have to be. They can be hydroxides, they can be iodines, they can be chlorines. We'll get there. For now, I have carbons. Okay, pencil or pen. Step 3. Step 3 is where we number our carbon chain to make the smallest numbers for our substituents. Okay, so this is the part where second hour started crying, so I need everybody to focus on me, not on what Cole's doing. Okay, ready?
Ready.
I'm going to count my chain, and I'm going to count it forward and backward to make Cole sit, to make the smallest number substituents. So 1, 2, 3, 4, 5. That's forward. I go backward. 1, 2, 3, 4, 5. 2, 3 is smaller than 3, 4. So that means I'm going to physically write my numbers in going forward.
What's the matter that's smaller?
Because some old white guy decided that was a rule. Didn't I lead with that?
I know, but
I said if you're going to ask me why.
Wait, why? I didn't actually expect you to say.
I wasn't kidding. Okay, so now we're ready to write. I start with my numbers. I'm going to start with a 2. Why? Because I have a substituent off a 2. I also have a substituent hanging off a 3. So 2, they're separated by a comma. Then I got a dash. What are they? Okay, so this is because I just learned this, I'm going to page back to here. They're 1 carbons. 1 carbons are called methanes, but since they're substituents, we change them, I'm leaving a little space, we change them, stop, don't talk over me when I'm teaching, to methyl. Okay, now Cole was talking at the same time as me, did you catch that? If it's a substituent, like it's highlighted in green, you change the ane to an ul, and that just tells the reader that it's a substituent, it's not the main chain. Since they are the same thing, they are twins, it's a dimethyl. Let's just preview our subscripts. What What is the word I'm looking for? Prefix, thank you. Di means 2, tri, thank you, means 3. Tetra, sometimes we forget, is 4. So if there was like 4 of the same thing, we would say tetramethyl. Penta is 5, but if you're using a penta, you probably didn't find the longest chain, to be honest, right? Because that'd be a lot of things. Okay, so 2, 3, di, because there's 2 of them that are the same. They're both methyls. And then last is my longest chain. My longest chain is 5. Going back, because I just learned this, 5 is a pentane. So 2, 3, dimethyl pentane.
So
That what?
that's 1 or 2 words.
This is 2 words. Good point. This is a space.
Oh. It's not die space.
No, it's not. I just left through the space. Okay. So I'm gonna keep color coding. My longest chain I did in yellow, so I'm gonna highlight the word pentane in yellow because that's where that came from. My substituents I did in green, so I'm gonna highlight that first part in green to see where they come from. Detail. If you have more than one different type of substituent, they have to go in alphabetical order, not including a prefix. So pretend that this was an ethyl and this was a methyl. My 2-ethyl would go before my 3-methyl in my word because E becomes before N. Okay, we'll do that. So, but for right now, just talk to somebody about where the green came from, where the yellow came from, and then we're going to practice with some samples. Thank you. Let's do some of these samples. So can you get out this worksheet? I'm going to still highlight each of the steps because you just heard it for the first time. Research shows you need to hear it 28 times over the course of 2 weeks to actually learn it. So we're on number 2. I'm going to use my yellow highlighter first because step 1 is to find the longest and continuous chain. Options. Bonk, 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 up. 1, 2, 3, 4, 5. This is a chain, but that's not obviously longest. 1, 2, 3, 4, 5. So I have 5 and 5. I'm going to do this just to kind of highlight what the carbons are, just because we're just learning. So is 5 my longest? Yeah. I'm going to use my green, my other highlighter, to look for substituents. Substituents are anything not hydrogen that's hanging off that main chain. Step 3 is to count forward and count backward, but make the smallest number for substituents. Why? Because somebody made that rule. But we're going to follow it because we have to. So going forward is 1, 2, 3, 4, 5. Going backward is 1, 2, 3, 4, 5. 2 is smaller than 4, so we're counting backward this time, okay? I physically write the numbers because that's going to help me when I do the longest chain and all of that anyways. I start with my number 2, give it a dash. What is it? It's a 1 carbon. 1 carbon, so I have my notes next to me. I look up 1 carbon. Methane, but since it's a substituent, I'm going to change it to methyl. It's not a dimethyl because there's only 1. Di means 2. And then last is my longest chain, which is a 5 carbon. I look at my notes to notice that it's a pentane. So that's a 2-methyl pentane. Now, if there would have been more than 1 substituent and they were different, so I had an ethyl and a methyl, the ethyl part would go first, then the methyl, but my longest chain always goes last no matter what. Okay? So, with your battle buddy, go ahead and draw. Now you're drawing. Go from the name to the drawing. Do number 1 to the right. Right? When I draw them from a name, I usually go left to right. So my 2-methyl is like the second from the left. Their 2-methyl was the second to the right. But it doesn't matter. They're just
silly.
okay, but now I want to do number 6. Looking for the longest and continuous chain. I have some options. 1, 2, 3, 4, 5, 6. Wonder if I can get bigger than 6. 1, 2, 3, 4, 5, 6, 7. Right.
1, 2, 3.
So now looking for substituents. Counting to make the smallest number for your substituents. Forward gives me 1, 2, 3, 4, 5, 6, 7, or, so what was that, 3, 6? Or 1, 2, 3, 4, 5, 6, 7. So 2, 5 is smaller than 3, 6, right? Numbers go first. They're twins. Twins get prefixes. What are they? And how many? Okay, now with your bad buddy, draw number 7. 3-ethyl, 3-methylhexane. Draw number 7. So your ethyl needs to have a corner, like bump, because you need to show the 2 carbons. Ethyl is 2 carbons. Not that you know that. You have your notes out and you're looking. Ethyl is 2 carbons, methyl is 1 carbon, and then your longest is a hexane. Now it doesn't say di because they're not twins. One's an ethyl and one's a methyl. Ethyl goes first because E comes before M. Okay, let's learn what to do with double bonds and triple bonds. Similar game, but maybe just a little different. So go back to your notes for a second. Okay, we're going to come back to that chart, so scooch down here. Alkenes are hydrocarbons that have double bonds. What we do is we change the ane part, butane, to ene, to butene. Propane is propene. Ethene, eth is 2. Ethene means it has a double bond. But carbon still only gets 4 bonds. So that means in total, it only has 4 hydrogens. How do I know? I draw it and I count it. 1, 2, 3, 4. 1, 2, 3, 4. Carbon can only have 4 bonds. So that leaves us with only 4 hydrogens. Alkynes are triples. We change the ane to ine. So instead of propane, it's propine. Instead of butane, it's butine. Instead of ethane, it's ethine. But each carbon still only gets 4 bonds. So that means there's only 2 hydrogens now altogether. How do I know? I draw it and I count them. Which is what the AP test is. Draw it and count it. It'll be like, draw it. What is the formula? No, then it's going to be like calculate the molar mass and then find the molecular formula. Like it's going to be like that, but you have to draw it to know what it is. Okay, so now let's go do a couple on the worksheet. You're going to have to turn the page.
Oh.
Can we do number 5? Let's do number 5. Longest continuous chain. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So is it just straight across?
It's where our double bond is.
So I have a substituent, a substituent, a substituent, and a substituent. Lots of them. This is going to be a big, long name. Okay, watch how I count. 1, 2 for the double bond. This double bond is off of carbon 2. It's like after carbon 2. So 1, 2, 3, 4, 5, 6, 7, 8. That's all right. 1, 2, 3. So this is going to be better because 2 is smaller than 3. So I'm going to count forward. 2 is smaller than 3. Okay, well you gave me a look like you just didn't get it. How to count? I can help you when we get there. I wish my marker wasn't so fat because
No, you can make it smaller.
I can. A little bit. Is this how you make it small?
For sure.
Okay.
But it just has to be square.
So now I got to think alphabet. This is an ethyl. 1, 2. That's an ethyl. This is an ethyl. 1, 2. This is a methyl. This is a methyl. My ethyls have to go first because E comes before N. You got the alphabet for it? You just don't have the pen. Okay. So my ethyls are 3, 4 because I have an ethyl off of 3. I have an ethyl off of 4. They are twins. Yes, you are. No. Okay, then I'm going to do my methyls. I have a 5, 6 dimethyl because I have 1 off of 5, 1 off of 6. They are also twins, so pick another. Oh, you're a twin too.
Wait, why?
Who's going to be the ethyls? Who's going to be the methyls?
I'll be the methyls.
Okay. 5, 6 dimethyl, but now last is my long chain with my ene. 2. Oh, I forgot my dashes. Ene. That 2 says my double bond ene is off of carbon 2. So 3, 4 diethyl, 5, 6 dimethyl 2-octene. Let's look at a triple bond because it makes the shape funny and it's kind of hard to see. Can you turn the page, please?
Yeah. Whoa.
I know.
Bro,
Triple bonds flatten them out.
let's do number 3.
Can we do number 2?
Yeah.
Okay. So where are the carbons? 1, 2, 3, 4, 5. There's here, here, and here. Those are where like my carbons are. Triple bonds, straighten them out. It takes out the jig-jag. Do you have to draw it straight? No. You can still draw it jig-jaggy. Just draw your triple bond in. Okay. So I'm looking for my longest continuous chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1. Okay. So I'm going around the corner. This. Right. Count. 1, 2, 3, 3, 4, 5, 6. 1, 2, 3, 4, 4, 5, 6. I have no idea what I said. What is smaller? 3, 3, 4, or 2, 4, 4. 2, 4, 4. 3, 3, 4, 2, 4, 4. 2, 4, 4.
2, 4, 4.
1, 2, 3, 4, 5, 6. Start with your substituents. 4, comma 4. I need to show both 4s. If it says dimethyl and I only put 1 4, then my question is, okay, but where's the other methyl? 4,4 dimethyl, 2, oh, hexyne. It's a triple bond. Yes. Can you draw 18 for me? Go ahead and draw 18. 4-methyl 2-pentyne. Practice getting that triple bond where it goes.
Did you give me a drawing quiz?
It's just like this, half a cat. Okay, what you have to do is you have to do your homework tonight because I have to move on tomorrow and you won't be able to do tomorrow's if you didn't do today. And you can barely do today's now, so you need more practice at it, which is totally what I would expect. So, all you're doing is all of this, but don't, number 5 here on the last page, these side flows, these circle shapes, I didn't teach you yet, so stop there. So that means, like, bring this packet along with you to classes the rest of the afternoon, keep working on it, or resource tomorrow, whatever, finish it up. Tomorrow we're going to learn what to do with iodos, chloros, bromos, cyclos, and alcohols.
Oh. Whoa. That's against the law.
If you're not 21,
Or in the United States. Here, here, all of you.